A diode circuits feeds an ideal inductor as shown in the figure. Given Vs is equal to 100 sine omega t volts, where omega is equal to 100 pi radians per second, L is equal to 31.83 millihenries, the initial value of the inductor current is 0. The switch S is closed at t is equal to 2.5 milliseconds. The peak value of the inductor current IL in the first cycle is. Now, given the frequency is omega is equal to, it is 100 pi radians per second. You know that 2 pi f is equal to, it is 100 pi. Then pi get cancelled, the frequency you will get, it is 50 hertz. Then the time period is equal to, it is 1 by 50, then it will be 20 milliseconds. Whenever it is 20 milliseconds, if I am taking 20 milliseconds is equal to, it will be 360 degrees. Because I am converting the seconds into degrees. Now, you know that from this 10 milliseconds is equal to, it is 180 degrees. That means 5 milliseconds is equal to, it is 90 degrees. 2.5 milliseconds means that it is 45 degrees. If you look at here, the supply voltage is a sinusoidal they have given. There is a diode and it is feeding to a pure inductive load here. Now, if you carefully observe it, diode has to start conducting from 0 onwards. But there is a switch here. Whenever there is a switch, and if the switch is closed at 2.5 milliseconds, means that it is indirectly, it is started at 45 degrees. Now, whenever diode starts conducting, when the diode starts conducting, now what will happen? If diode starts conducting, if I am taking the voltage across the inductor, VL, you know that this is the source current, this is diode anode to cathode current and inductor current. All are same. So IS is equal to ID is equal to IL. All are same. Too many variables are confusion for me. That is why I am indicating a simple term called I. Now, whenever the diode starts conducting, then VL is equal to Vs. It is VL is equal to Vs. Now, what is happening? Can I represent V? Can I represent Vs, Vm sin omega t? You know that Ohm's law across the inductor, I is equal to 1 by L integral VL into dt. If I am writing here, then this is equal to 1 by L integration VL is equal to, you know that VL is equal to Vs, that is equal to Vm sin omega t. Vm sin omega t, this is dt. Now, where the switch is started, the switch is only closed, it is not 0. It is started at 2.5 milliseconds. Then, if it is 2.5 milliseconds, then where it is ending, I don't know that. That is the reason I am indicating it is T. Now, because when the switch is absent here, if the switch is not there, here, then the diode starts conducting at 0. Whenever it starts conducting at 0, then the time is assumed to be 0. T is equal to 0. Then what is the current? If I am writing I is equal to, it is Vm by L integration of sine can be represented as minus cos, and inner derivative will be omega, and this will be 2.5 milli, and this is I don't know that. Now omega is taken outside, and if I'm substituting lower limit first and after that upper limit next, Vm by omega L, this is cos omega into 2.5 into 10 power minus 3 minus cos omega t, because this is the upper limit. Now what is happening here, if I'm doing it, it is I is equal to if I'm taking, it is Vm by omega L, it is omega t, it is nothing but it is in degrees or in radians. Already I told you it is 2.5 milliseconds. If I am converting into degrees or radians, it is omega t. What is omega t at 2.5 milliseconds? It is 45 degrees. Then cos, it is 45 degrees minus, it is cos omega t. Now if you look at it very carefully, the peak value of the current I, the current I is equal to Vm by omega L into cos 45 minus cos omega t. In the question, they have asked very clearly, they have asked the peak value of the inductor current in the first cycle. You know that the peak value of the current will appear at omega t is equal to 180 degrees. If you take it, it is 180 degrees Vm by omega L into cos 45 minus cos omega t, that is equal to 180 degrees. Cos 180 is nothing but minus 1. Minus of minus, it will becomes as plus 1. This will be Vm by omega L. It will be cos 45 is nothing but it is 0.707. This is minus 1, and this will be this will becomes as 1.707 times of Vm by omega L. Now if you take it Vm, the Vm they have given in the question, it is 100, and omega is given as 100 pi, and L they have given it is 31.83 millihenries. Then if I am substituting, it is 1.707. It is Vm is nothing but 100 by, what is this? It is 100 pi into 31.83 into 10 power minus 3. This will be 17.07 amperes. The final value of the answer is, the peak value of the inductor current in this case is 17.07.